Hello everyone, welcome to ISRO Academy's YouTube channel. My name is Arjun Chabra, I'm faculty at ISRO Academy and ACE Online platform. In this today's session, we'll be following up our ISRO series with the construction materials topic over here. So, in construction materials, we'll be delving into the topics which have been asked a lot. Now, most of the questions which have been asked from construction materials, they have been from cement, they have been from concrete, a bit from bricks and timber, right? And some other miscellaneous topics have also been asked here and there, but major topics to be covered are cement and concrete. Most of the questions you would see that they are being asked from these two. Apart from that, bricks and timber, if you'll also cover, you'll be on a safer side, right? And there is very difficult thing that you can say that okay, some other miscellaneous materials you will also cover because syllabus is more, but time is less, right? So best way is just revise the topmost topics, that is cement, bricks, timber, concrete, and brush up your skills and brush up your concepts from these topics itself. So let's dive into the questions one by one. So over here, it's a very, and moreover, the questions which have been asked in ISRO are very simple, right? Not like engineering services, they have been asking. So keep this in mind. You will witness very basic questions in this, very straightforward questions you would see. So over here, they are saying the compound formed due to the interaction of oxides present in the raw materials of the cement in kiln at high temperature. They are all obviously called as, when intermixing of the constituents of cement happens, it will be called as what? Box compounds. So what are box compounds? Box compounds are the raw materials like limestone, clay, etc. When they are heated up in kiln at high temperatures, the constituents interact and they generally form box compounds. And what are your box compounds? There are 4 box compounds. Each have their own properties. C3S, tricalcium silicate, C2S, dicalcium silicate, C3A, tricalcium silicate, and C4AF, tetracalcium aluminoferrate. Now, strength producing box compounds are mostly C3S and C2S, and C3A is primarily a setting compound, right? If in excess it leads to flash setting of your cement. And C4AF has very less engineering significance, so mostly the work is being done by the top 3 box compounds over here. Now, these determine the strength and the setting properties of the cement, right? So these are the 2 main criteria which are required to be seen when we are judging the quality of cement. So strength and setting are the 2 main things which are being handled by these box compounds, right? Apart from that, next question, let's see. In a manufacturing of cement, the dry and wet mixture of calcareous and argillaceous materials are burnt at a temperature of, so they are burnt at a temperature of 12 to 1500 degrees Celsius, precisely close to 1400 degrees Celsius, you would see the temperature in the kiln. Now, the burning or the clinkering zone temperature where actual cement compounds are found, it ranges from 12 to 1500 degrees Celsius, but it is close to 1400 degrees Celsius. And in most of the books, you would see that the temperature has been mentioned as 1400 degree Celsius. Now, after that, they are saying the soundness of the cement is measured by, so yes. So it is measured by your Lee-Chatellier's apparatus. We test out the change in the volume after setting of the cement. So over here, when we say soundness of the cement, it is the ability of the cement to retain its volume after setting. Now, the change in volume is primarily due to the expansion or excess of free lime which is present or magnesia which is present, right? And it is tested by either Lee-Chatellier's apparatus for free lime and by autoclave testing for magnesia. So this is some other information which I am telling you, which can be useful for your revision. And you can see the other options which were mentioned for clarity over here. what are they? So wicket apparatus is used to determine the setting time and consistency of the cement. After that, its rebound hammer test is a non-descriptive test used for the surface hardness and strength of concrete. And also ultra sonic pulse velocity test is also a non-descriptive test used to check the homogeneity and quality of concrete, right? So these are some other options for your revision, basic revision. You can just check it out also in your free time as well. Apart from that, here what they are saying, the amount of water required for the complete chemical reaction of the cement is. So for the chemical reaction of cement, we generally need 38% by weight of cement, right? Now how it is? So for ordinary Portland cement, for complete hydration, we need 23% water by weight of cement for complete hydration. But some of the water is also occupied in pores. So how much water is there? 15% of that water will be there. So total will become 23 plus 15, which is equal to 38% by weight of your water which will be required as minimum. Generally, we provide minimum 0.4 and we range it from 0.4 to 0.6 for cement. So if you are increasing the water cement ratio also, there will be a compromise with the strength of the concrete, of the cement as well. Now, after that, they are saying high percentage of tricalcium silicate in cement results in, so it will result in high early strength because C3S, so strength is produced by two of the four Box compounds, that is your C3S and C2S. C3S is responsible for early strength and C2S is responsible for later stage strength. So over here, as we know that it hydrates and hardens quickly, and mostly within the 7 days, first 7 days, you would see that the strength is being produced by C3S, and beyond that it will be C2S, and the amount of heat which is generated by C3S is more than C2S. So over here C2S, it hydrates and hardens slowly, and it is the compound which produces strength at later stages, right? So it contributes to strength at the later stages. Keep this in mind. Next one is, here they are saying for marine works, the best suited cement is. So best suited cement will be your blast furnace slag cement. Now blast furnace slag cement has a special property that, okay, it is helpful, especially in the case of marine works and any kind of work which is there in relation of water. Now over here, it can resist sulfate attack. This is the special property of blast furnace slag cement, and chloride penetration can also be prevented from seawater. So let's just briefly see what just blast furnace slag's properties are. So it has low heat of hydration. Also, it has high resistance to sulfates and chlorides, and moreover, best suited for marine and hydraulic structures, right? So you can just note these points up because you would see that, okay, in some way or the other way, these points have been asked in various other competitive examinations as well. Next question is there, what they are saying, which type of following cement is used for the mass concreting works. So for mass concreting works, mostly you would see low heat cement. Now, especially because of the fact that you would see that mass concreting works are mostly required in structures like dams, rough foundations, large retaining walls. Point is heat of hydration. So rise of temperature would be quite high, right? It will be a major problem because we are using concrete in bulk. So it can lead towards thermal cracking, right? So in that particular case, low heat cement will come up. So what is your low heat cement? It produces less heat of hydration and slower strength gain, but ensures long-term durability, right? Used mostly for mass concreting works. You have to keep this in mind. Basic points I'm just telling you in the middle because of the fact that, okay, you are revising these concepts. It will be helpful for you. Now, apart from that, here they are saying the specific surface area for 53 grade ordinary Portland cement should not be less than, so it should not be less than 2 to 5 meter square per kg. Now, over here, the IS code which you need to refer is IS 269, and that is 2015. So what shall be considered over here? This code is for ordinary Portland cement. So previously what was the case was for OPC grade 33, OPC grade 43 and OPC grade 53, the codes were different, right? Now all of these codes have been merged in IS 269 2015. You would see that all of the grades are over there only, and you can refer it that it is 225 square meter per kg. Next one is largest constituent of ordinary Portland cement is. So it is actually lime. So answer is what? A. So lime is your maximum utilizing space inside the cement, right? Largest constituent in the cement. So briefly, what are the constituents of cements? We can see it over here on the screen. So approximate oxide composition in limits of OPC, you can see all of these are the constituents of lime, 60 to 67%, silica 17 to 25%, alumina 3 to 8%, iron oxide 0.5 to 6%, magnesia 0.1 to 4%. Alkalis are very undesirable. We generally tend to not have them a lot. They are a problem for us in many ways, especially in terms of alkali aggregate reactions and also efflorescence on the surface. So 0.4 to 3%, and then sulfur comes 1.3 to 3%. So this is your total constituents which are there. Now alkalis are not added by us actually. Alkalis are present in the raw materials. We have to see the quality of the raw materials which are being used to manufacture cement, right? So alkalis is not added by us mostly. It is what? The undesirable things which comes with the constituents. Next one is the initial setting time of OPC shall not be less than. So for OPC, it should not be less than 30 minutes, right? It should not be less than 30 minutes, and final setting time 10 hours. So option C. Next is the Blaine's air permeability method is used to determine. So why would you use Blaine's air permeability method? So Blaine's air permeability method is used to check the soundness of cement, or you can say the specific surface area is being tested by it. Now in that, what you do is you just pass on the air through a bed of cement. Through a bed of cement, you would pass it, and you would see, let's say Y is the head over here of the pressure head, and then Y dash is there. So you would see how much pressure head is being lost through that air, through that bed of cement. So Blaine's air permeability method measures the fineness of the cement precisely. Right? I'm very sorry about the previous answer. It is fineness of cement, and through the beds, it will be judging up the specific surface area centimeter square per kg or meter square per kg. And what is the principle? So an airflow through the bed of the cement will be passed. Airflow through the bed of the cement shall be passed in this way only, in which I showed you. It will be compacted through cement related to the surface area. Finer the cement, higher will be the head loss, right? More head loss would mean what? Finer cement is there. Next is soundness test of cement determines. The soundness test tend to determine how much quantity of free lime is there. So free lime tends to test the soundness of cement or changes in the volume of cement. The cement content is very much lime content is very much responsible for that, right? Now in this you can say that the soundness of cement is actually the ability of the hardened cement paste to retain its volume without delayed expansion. And the unsoundness is mainly due to what? Excess of lime and magnesia, as told you previously as well, which can slowly hydrate and cause expansion, cracking, and disintegration of cement in the concrete, right? So we have to keep it in mind that it has to be measured. So in previous questions also we have seen this. It is generally tested by Lee-Chatelier's apparatus for free lime and autoclave test for magnesia, right? In the previous questions also we have seen. And you would also see one more thing is that in questions of building materials, a lot of questions have been repeated also, right? Okay. The minimum cement content of cement specified by IS 456-2000 for adoption in concrete work with normal weight aggregate of 20 nominal size is. So here minimum cement content dependency is considered. So over here they are saying it is independent of exposure conditions. No, it is not independent of exposure condition. It is actually dependent on exposure conditions. Independent of grade of cement. So yes, it is independent of grade of cement actually. Answer B shall be there. And it is independent of type of concrete, that is plain or reinforced concrete. No, it is not. It is dependent on that. So actually this is given in the table number 5 of IS 456. You can just check it out if you want. Right over here you can see the exposure conditions and minimum cement content dependency on the exposure conditions. Afterwards, the minimum cement content for plain concrete and reinforced cement concrete is different. So therefore, and here in this entire table you cannot see the consideration of the grade of cement which is being used over here. So it is independent of the grade of cement. We have to move forward corresponding to that. Okay. Next is, you can just check it out. Efflorescence in cement is caused due to the excess of. So efflorescence will be caused due to the excess of alkalis, as I told you previously. Alkalis is a very big problem for us. When we talk about alkalis, so alkalis, they are generally present in the raw materials specifically, right? Raw materials which are being used to manufacture cement. Now, in excess, they causes alkali aggregate reaction. That is a problem for us. And efflorescence staining, that is white patches on the surface, there will be a problem because of alkalis only. In excess of 1%, it fails the concrete, right? It fails the concrete. When I talk about IS 269-2015, as per that IS code, alkali content should not be greater than 0.6% actually, right? But generally it has been seen if it is greater than 1%, there can be a loss of strength in the concrete. And one more thing, if alkali content turns out to be very high, the engineer in charge on the site itself, they can ask for a certificate corresponding to how much alkali content is there from the manufacturer to be on a safer side, right? So all of these provisions, you can see them in IS 269 only in manufacturer's certificate topic. Apart from that, here, if 1000 grams of sand is sieved through 4.75, 2.36, 1.18, okay, 600 micron, 300 micron, 1500 micron standard sieves, and the percentage retained weights, percentage retained is already given. So 0, 100, 150, 200, 350 and 200 respectively. Then the fineness modulus, what is there? So answer for this will be 2.6. Answer for this is 2.6 actually. So what I have done is I have made a table to save time in this. So over here I have placed all the sieve sizes. So this will be what? Very much quick in your examination actually, right? You'll be doing that on your rough paper. But what I have done is I have made this initially before starting off the session itself. So these are your sieves and the percentage weight retained, the weight retained, how much weight is retained, it has been mentioned in the question itself. So over here, as you can see, the percentage retained weight also you can find it out. Total weight is 1000 over here. So from that you can find out what is the percentage weight retained. And then cumulative percentage weight retained. So 10, 10 plus 15, 25, 25 plus 20, 45, 45 plus 35, 80, 80 plus 20, 100. And then there is 0. So we'll end it over here. So how much total you are getting over here is, let's see. So 10, 35, 35, 80, 160 and plus 100. So it is 260 is the total you are getting. Fineness modulus will be this divided by 100. So you'll be getting 2.6 as the value of fineness modulus, right? So 2.6 will be the answer in this particular case. And some extra information you can just keep it in mind based upon fineness modulus and their classification. In some state level examinations, this has been asked, so you can keep this in mind. So fineness, fine sand will be having the fineness modulus from 2.2 to 2.6. Medium sand, it will be having 2.6 to 2.9. Coarse sand will be having 2.9 to 3.2. So these considerations, please keep it in mind in regard of fineness modulus. This classification is seen in a couple of competitive examinations. Apart from that, for a given aggregate ratio, the increasing in water cement ratio would lead to what? So water cement ratio is very crucial for us. We do not want too much increase in the water cement ratio. Increasing in water cement ratio can help us with workability as well to some extent, but there is a huge problem of shrinkage and the loss of strength which can come along with increasing the water cement ratio. So we have to keep this in mind. So increasing the water cement ratio actually increases shrinkage. That shall be the problem for us, right? So we have to keep this in mind. So corresponding to all of these points which I have told you over here, so if water cement ratio increases, more water in the mix will be there and more pores will be present after the evaporation of water from that, and low strength and higher shrinkage will be observed in that particular case. If water cement ratio decreases the optimum level, the denser concrete will be there, right? Stronger concrete will be there, but workability would be very hard. So we have to manage between the workability and the strength which is desired out of the water cement ratio, right? So what are the effects of higher water cement ratio? Strength decreases, permeability increases, shrinkage increases, durability reduces, right? So these are the main points which you need to keep in mind based upon the questions which can be asked. So in just a short form or shortcuts I have mentioned just for your revision purpose over here. Apart from that, let's see the next question over here. Next question is saying the fineness modulus of fine aggregate is 2.78 and that of coarse aggregate is 7.82. The desired fineness modulus of the mix is 6.14. What is the amount of fine aggregate to be mixed with one part of coarse aggregate? So you can just find it out in a simple format only. So fineness modulus of the mix will be considered, let's say I am considering percentage P, or P is the proportion of fine aggregate plus 1 minus P proportion for fineness modulus of coarse aggregate, right? You can just do it like that. And over here, fineness modulus of the mix is 6.14. Here, fineness modulus of fine aggregate is 2.78 plus 1 minus P, and fineness modulus of coarse aggregate is 7.82. Right? So once you'll solve this, you'll get 3.33. Sorry, not 3.33, 0.33 as the value of P you'll get, right? You'll get 0.33. So fine aggregate is in the proportion of 0.33 and coarse aggregate will be then 1 minus P. So it will be what? 0.667, right? So fine aggregate is to coarse aggregate, right? What is the proportion? It will be 0.33 is to 0.667. That means 1 is to 2. So half proportion, 50% proportion will be there in this particular case, right? So 50% proportion will be there. So if we'll get the value of fine aggregate as 0.33 over here, and then this ratio will turn out. So 50% shall be the consideration. Answer would be B over here. Next. Here they are saying how much the fineness modulus of aggregates approximately is directly proportional to the average size of the particle, inversely proportional to the average size of the particle, indicates the water absorption of the aggregates, indicates the modulus of elasticity. Answer would be A over here. It is directly proportional to the average size. So fineness modulus will be higher for higher size particles and lower for lower size particles. So keep this in mind. Higher the fineness modulus, it would correspond to coarser aggregates, large average particle size, and lower fineness modulus will be corresponding to finer aggregates. That would mean smaller particle size consideration over here, right? So these are the things in terms of fineness modulus. Now, separation of coarse aggregates from the motor during the transportation is known as. So, what are they saying? Separation of coarse aggregates from motor during the transportation is known as. It will be called as what? Segregation, right? This is generally done when it happens whenever the water amount is high and you have not controlled the amount of water which is present inside the mix of motor. So next one is, what they have done is in this particular question they have directly copied the statement from the IS 456 only. So here they are saying that forms of freshly laid RCC work should not be struck for a period called as dash until the concrete has reached a strength at least twice the stress to which the concrete may be subjected to at the time of removal of formwork. So over here they are talking about after how much time is it prescribed in the IS 456-2000 to remove the formwork, right? So it is corresponding, the time corresponding to that is stripping time, right? The time corresponding to that is stripping time. So keep this in mind. So stripping time is the time which the name which is used for the time after which the formwork shall be removed, right? So it is for development of substantial strength in the concrete actually. How much? Twice the stress to which the concrete may be subjected to at that time. So what I have done is I have taken out the table from IS 456-2000. Now the formwork, the type of formwork which is to be considered over here for various structures like columns, walls, beams, slabs, right? So for formwork for columns and walls and beams, it is 16 to 24 hours. And then the soffit or the ending of the slab to which we have provided the formwork to, it is 3 days. Soffit formwork to the beams, the lower level, 7 days. Props to slabs spanning up to 4.5 meters, 7 days. Spanning over 4.5 meters up to 14 days. And props to beams and arches spanning to 6 meters, 14 days. Spanning over 6 meters, 21 days. So it's up to you that if you want to just memorize all of these values or not. In some cases, in some examinations, these values have been asked, right? And I'm talking about not GATE or engineering services. I'm talking about state level AJE examinations, they have asked these values. Apart from that, the addition of calcium chloride in concrete causes. So calcium chloride addition actually causes the retardation, it causes the reduction of curing of period, right? Reduction of curing period will be witnessed. So actually calcium chloride is not used nowadays because of, it's an accelerator actually. It helps in the rate of gain of strength, right? So the strength gain is quicker. So if strength gain is quicker, the concrete will harden quickly, right? So if concrete will harden quickly, the amount of curing which will be required will be less in that case. So hydration process of C3S is accelerated because of calcium chloride, and this allows a reduction in the curing period. But we generally do not use calcium chloride nowadays because calcium chloride can corrode the reinforcement. That is the major problem with calcium chloride. So we generally do not use it as accelerator. We use various other alternatives. Workability of concrete mix with low water cement ratio is determined by, so when water cement ratio will be less, in that case we will not be using slump test. See, tensile strength test and flexible compressive strength tests are just strength checking techniques, right? They are talking about the tests. The workability is judged by these two tests. There are other tests also. There's flow test, BB consistometer test, but slump test, compaction factor test works out in most of the cases. In slump test, you will be judging the workability of medium concrete, right? So medium type workability you will be checking with the slump test. High workability, flow test you use. Compaction factor is generally used for concretes with low workability, right? So keep this in mind for this particular answer. For low workability means whenever low water cement ratio will be there, the cement concrete mix will be having low workability in that case. In that case, you would be using compaction factor test. Next one is the strength of cement concrete primarily depends upon. So strength of cement concrete, is it dependent upon quality of water, quantity of water, quantity of cement? See, all of them are individually influencing it, but all of them combined can be considered, not combined, quality of water does matter. But over here, the most significant answer would be water cement ratio, right? So over here in this option, you are just covering up the effects of water as well as cement, mostly on basis of quantity in this one option only, right? Option D. So over here, option D will be the correct consideration. Water cement ratio is very good, but quality of water is also very important, right? If quality of water is not matching up with the IS 456 provisions, on later stages, it may affect the durability of concrete, right? So the type of water which is being used in the cement concrete mixing is also very, very important. You may have used world-class quality materials, world-class, cement is being used, the fine aggregates, coarse aggregates being used. But if the quality of water is not up to the mark, it will lead towards less durability of concrete. Here, next one, higher water cement ratio in concrete results in. So higher water cement ratio would result in the two things. Let's see. Better workable mix will be there, higher water cement ratio, but it will be a weak mix, right? Weak mix because of the fact that cement content will be less. So it will be a leaner mix as compared to lower water cement ratio. So over here, option B shall be the correct answer. Next one, the slump test is used to measure which of the following properties. It is used for workability, as told you previously. Next, here they are saying the approximate ratio between the strength of cement concrete at 7 days to that of 28 days. It is 2 by 3. It is 67% approximately of the 28 days strength. Next one is the general ratio of cement sand aggregate in nominal mix M20 is. So it is 1:2, 1.5:3 for M20 concrete mix. So I have made a table over here. You can just refer it up. M10, 15, 20, 25, 136, 124, 1.5:3, 112. So these can be used directly in your examinations. You can just memorize this as well. These are the nominal mixes. Beyond that, you need to go for design mix as per IS 456-2000. Next one is a first class brick should not absorb more than dash of its dry weight, right? Moisture content in 24 hours. It should not be more than 15%. Actually, it should range between 12 to 15% for first class bricks. For first class bricks, the dry weight absorption, water absorption shall be not greater than 12 to 15%. So keep this in mind, 12 to 15% for first class bricks shall be there. The crushing strength is not less than 10 Newton per mm square. Second class bricks should not absorb more than 15 to 20%. So beyond that, if it is absorbing, it is a second class brick. Crushing strength shall not be less than 7 Newton per mm square. Also keep it in mind the fact that third class bricks are also there. Here the water absorption shall not be more than 25%. Though the strength is less for these kind of bricks, they are floppy bricks, they are generally used for temporary structures. Apart from that, what is the standard size of a brick? So without the mortar, it is 19 centimeter, 9 centimeter by 9 centimeter. With the mortar, it will be 20 by 10 by 10. Now after that, here they are saying excess of alumina in clay, which is being used for the brick, will result in warping of the brick and cracking of the brick actually, right, on drying. So this is the problem in respect of excess of alumina. So let me just show you the constituents of a good brick earth briefly. Just brush up your concepts over here in this question itself, right? So I'll not repeat the questions, right, because repetition of questions is useless. So number one is what? Silica, which is being used. So silica, brick earth shall not be, should contain about 50% of silica. Responsible for preventing cracking, shrinkage, warping of raw bricks. And it also affects the durability of the bricks. Apart from that, if present in excess, then it destroys the cohesion between the particles and become very much brittle. This is the problem with what? Silica over here. Next one is alumina. Alumina in the good brick earth will be 20 to 30% of alumina shall be there. Apart from that, it is responsible for plasticity characteristics in the earth, right? The clay which is being used to manufacture the concrete, the bricks actually. If they are present in excess, raw bricks shrink and warp during drying. So this is the problem which was asked in the question. Apart from that, the other one will be your lime. So lime is a very important constituent. Percentage of lime should not be, should fall in the range of 5 to 10% for a good brick earth. It prevents shrinkage of the bricks on drying, and also it causes silica in clay to melt on burning and then helps to bind it. Apart from that, excess of lime causes the brick to melt and brick loses its shape over here. Right? This is a very big problem. Next one comes iron oxide. Iron oxide should be in the range of 5 to 7%. It generally provides red color to the bricks. It improves the impermeability and durability, strength and hardness to the bricks, right? So if they are present in excess, the color of the brick becomes dark blue and blackish, right? So if iron oxide is in excess. If the quantity of iron oxide is comparatively less, the brick becomes yellowish in color. That is a color difference which you get because of iron oxide. Now, after that, next one is magnesia, the last one. Here, good brick earth should not have should have very less quantity of magnesia, actually about 1%. Magnesia in brick imparts yellow tint to the brick. If it is in excess, it can lead to unsoundness. It is responsible for reducing shrinkage, right? So excess of magnesia leads to decay of the bricks and also unsoundness, right? So these were the considerations with respect to the constituents of the bricks. After that, a brick which is cut in such a way that width of its one end is half of that of full brick. So actually it will be a beveled closure. So what we are doing is, let's say, beveled closure. So it will be like this. So you can see the full brick. So one width is what? One width is half of the original one. Another one is the same as that of the original one in the beveled closure, right? King closure, you can see half of the header and half of the stretcher cut, the corner is cut, king closure. Queen closure is completely 50%, half of the width on both the sides and cut it from the between. Queen closure quarter, you can also say a quarter of that is being taken. And metered closure at an angle of 45 to 65 degree if you are cutting the brick. So these are what? Closures which are there, okay? And apart from that, these are bats. So half bat, cutting the brick into half along the stretcher. 3/4 bat, cutting the 1/4 of the width length or stretcher. And beveled bat, cutting it at an angle along the stretcher, right? So these are the considerations of cutting for various bonds which we need to make in brickwork. The purpose of seasoning of timber is to reduce the moisture content, right? So there are a lot of processes which are required for timber processing, cutting, seasoning, then afterwards, making shape out of it, and then afterwards preservation will be there. So seasoning of timber is in the IS code IS 1141. So for seasoning of timber, this is the IS code. Apart from that, newly felled trees have almost 50% of moisture content inside of them. Keep this in mind. So it is actually available in the sap portion of the cross section of timber. So seasoning allows the ease in burning, reduction in weight, transportation cost will be reduced, increase hardness, strength, and make it more workable. It is easy to convert it, right? Conversion of timber is easy. Reduction in tendency to crack, warp, shrink, and to increase the attack against fungi and termites. Ease in gluing as well. It is easier if the timber is seasoned. And it can be done by boiling, chemical, electrical, kiln, and water seasoning. So these are the multiple ways of seasoning of timber. Now, after that, they are saying in the inner part of the timber log surrounding the pith, not pitch, pith. This is what pith is called. So it is called as heartwood. So you can see it over here in the pith. Surrounding that, there will be what? Heartwood. So after the pith portion, there will be heartwood, then there will be sapwood, and then you would see vascular cambium layer over there. Okay. Now, apart from that, how would you measure the age of the tree? So age of the tree is measured by the annular rings. So annual rings are responsible for the age. So number of rings will tend to tell us about the they would tend to tell us about the They would tend to tell us about the age of the timber. So yeah, so these are the questions which have been mostly asked in our examination. So what we need to do is we need to revise in such a way only. Concepts, then questions, or questions, then concepts. So whatever the concepts are there, especially in terms of building materials topic, try to revise it in this manner only. The purpose of this video was purpose of this session was just to uh, help you understand that how to revise through questions. So once you read a question, go for the concept. Once you read a question, go for the concept and related concepts also in your notes, right? So in such a way, you are doing two things at one time. You are also revising your questions. You are getting familiar with the type of questions, level of questions which have been asked, and also the concept revision part is also going along with that. So this is the way to revise building materials topic. So thank you for watching. If there is any doubt, please comment down in the comment section. I'll reply them personally. I'll see you in the next video.